Hey guys, it's Mathematics YT. Today we are going to prove the derivative of a polynomial function, and we are going to do this without find the pattern, because if we are learning at maths, we are learning about differentiation. When you want to prove the formula to someone, then you should find a pattern. Or I will let n equal to 1, let n equal to 2, let n equal to 3, and track the pattern and solve this thing out. But for me, I will just directly use the variable n, which means I have two variables. But don't worry, n is just a constant, while x is the variable. So if you learn at math style, you should know that the derivative of x power of n is equal to n times x power of n minus 1, and this can prove the definition of derivative. So I will just write DOD. The definition of derivative is f of x plus delta x minus f of x over delta x as delta x approach 0. And this is the definition of derivative. And whenever we have whenever we want to differentiate a function, we can use the definition of derivative to solve, but that will take a lot of time to do. So we need a formula to simplify this thing out. So this will make the differentiation straightforward. Well, because when you have polynomial function, then you can then you can differentiate one term by one term. Then let's say x power 6 plus 4 times x power 5, so that's 6x power 5. Wait, I forget whatever. Just one term by one term differentiate, and when you want to prove this to someone, you are going to do some pattern, because that's what everyone can do when you're learning differentiation. So you let x is you let n is equal to 3, you let n is equal to 2, and then you find the pattern, then you can solve this thing out. And yeah, that's what everyone can do. But in this video, we will just going to use the n. Yeah, straightforward with the n. So when we want to differentiate expression, we must use this definition of derivative. So by plugging this function to each of these, then this is equal to delta x approaches infinity. Well, I just write this first. Then x plus delta x power of n minus x power of n divided by delta of x. Now here is the problem. You guys we cannot express this into like one expression, because if you have found the pattern on solving by expanding the exponential binomial, then you can conclude that, let's say a plus b bracket power of n is equal to the sum of NCR times a with power of n minus r times b power of r, while r goes from 0 to n. And yeah, if you have solved so many exponential binomial, and you figure out a pattern, and this is what you get, then you plug this into here. So compared to the expression, a is equal to x, b is equal to delta of x, and then plug this thing here, so I will plug this down. This thing is equal to the sum of NCR times x power of n minus r times delta x power of r as r goes from 0 to n, and minus x power of n divided by delta of x as delta of x approaches 0. And delta x, let's say it is a constant, then we can just divide this both. We can just plug this to here by using the law of indices. So this is equal to delta x approaches infinity, 0, and the sum of NCR x power of n minus r times delta x the power of r minus 1 minus x power n over delta x as r goes from 0 to n. And you must be careful. Now we can plug in 0. No, we cannot, because if plug in 0, then this 0 power of r minus 1, which will make things all 0, but it makes sense. But wait, I will explain why we cannot. This is the first reason, and the second reason is this x power of n over 0. That sounds bad, okay? That sounds bad. Now back to here. Why we cannot straight away plug 0? This is clear, because x power n over 0, that sounds bad. I don't think we can do this. It's not good. Now, if we plug in the 0 here, straight away plug in, then 0 power of r minus 1 is equal to 0. But wait, when we expand this expression, now if you know how sigma works here, how it works. Now if we have a term, let's say f of n, and n goes from a term to this here, then this is defined as f of a plus f of a plus 1 plus f of a plus 2 blah 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 until plus f of b minus 1 plus f of b, and you're going to sum it up. Yes, because sigma is means the sum of notation. If you are learning maths or mathematics, you always see only this symbol. But if you are the true form of the sigma, the sum of notation. And why we cannot straight away plug it? Because of the expansion of this expression. Well, now if I expand this, then 0 minus 1, that's negative 1. Now delta x power of negative 1, if I straight away plug in 0, what will happen? 0 power of negative 1, that's infinity. So that sounds big, so I have to exclude it out. So I think I will use the back to this paper. Now as I said, that if I straight away plug in, we cannot, because 0 power of negative 1, that is negative 1. Then delta x power of negative 1, if I plug in 0, then it's equal to 0 power of negative 1. So that's infinity. So that sounds bad. So I will exclude this. Now remember the definition of this sum of notation. F of n is equal to sum of f of n from n is equal to a to b is equal to f of n. So I will take it out. I will exclude the first term. So this thing, this is n. This thing is equal to, now the first term, r is equal to 0. NCR, you should know that C is the means combination, and r as 0, it becomes, as r is equal to 0, then NC0, that should be equal to 1. So 1 multiplied by r n minus 0, so x power of n, then r minus, then this is, here. Now this is, if I plug in this, NC0 is equal to 1, n minus 0 it's n, and 0 minus 1 is delta x power of negative 1. So all over delta of x plus the sum from r is equal to 1, because you excluded out the value of this as r goes from 0. So it is equal to x power of n over delta x. I exclude it out because if I straight away plug in 0, that sounds bad. So this plus the sum of NCR still the same expression, x power of n minus r times delta x power of r minus 1. So goes from r is equal to 1 to n, and minus x power of n over delta x. And look at what I have here, and of course the limit as delta x approaches infinity. Now look what I have here. This is the positive version of this, is a negative version of this term, so which means that this minus this becomes 0, cancel out, and what I have here is this. Now can I still plug in 0? Still cannot. Why? Because as r is equal to 1, 1 minus 1 is equal to 0. If I straight away plug in 0, then 0 with power of 0. What is that? Now 0 power of 0, that is also one of the intermediate operation where you cannot conclude the value of the 0 power of 0 in many ways, because you get different value in plenty of ways. So which means that 0 power of 0 is inconclusive, which means that it sounds worse than 0 power of negative 1. So I also need to exclude out this expression as r is equal to 1. So this thing is equal to the sum of r is equal to 2, and still the same expression, and it goes from n, and let's figure out the value of 1. Now NC1, so NC1 is equal to n multiplied by x power of n minus r. Now x power of n minus r is x minus 1 multiplied by this 1 minus 1 is equal to 0, so times 1, so what I get here is this. Now here's the question: can I straight away plug in 0? And of course I always forget this delta x approaches 0, because the definition of derivative needs a limit. And now can I straight away plug in 0? Yes, you can, because and when r is equal to 2, then 2 minus 1 is 1, and 0 power of 1 is 0, and when it goes from r is equal to 3, 3 minus 1 is 2, so plug in 0, you also get 0, which means that you can legitimately plug 0 to this. So when I plug in 0 power of this, you always 0, as because the lower limit is always plugged in and it is greater than 0. And when this becomes 0, then whole thing is equal to 0, which is equal to 0 plus nx power of n minus 1, because the delta x already left, so we no need to plug the limit of the delta x because there's no presence of delta x. So 0 plus n times x power of n minus 1. So this leads us to the n times x power of n minus 1, and we are done without using the pattern. And yeah, if you use the pattern, then it is okay for you, but for me, I will straight away use the variable n, because if you can see the pattern of expanding exponential binomial, then you can see, then you can conclude with the expression like this. And as always, if you want to see more the proof of something, subscribe to the channel and leave a like to this video, and I will see you guys next time in another video.